What is up everybody, I'm Ritvik Dashura and I'm back with a video and some new learnings. And this video is an extension of the previous video, which was on simple and multiple regression analysis. This was the code that we actually made in the previous video. I used housing.csv data in order to make it, and we saw how to do simple regression analysis and how to use all the parameters, that is multiple regression analysis. If you have not watched this video, I would highly recommend highly recommend you to watch this video first and then come back and watch this one. I'm not going anywhere. The reason is I used a different library in the previous video, which was stats model. In this one, I'm going to use Sklearn. The reason I'm using a different library is that we should have a different learning all the time. Still, I like the stats model library more than the Sklearn. I'll tell you what are the pros and the cons of Sklearn library. Different people have different opinions on these libraries, but I like stats model more than Sklearn for regression analysis. Perfect. So we can start it. Yeah, but before starting it, I would like to have a request. If you have not yet watched this, if you have not yet subscribed to my YouTube channel, then please click on the subscribe button down below and also hit on the bell icon. Also, if you go to my YouTube channel, you can see there is a button here which is access to my Google Drive, and if you want to have a free access to my Google Drive where I save all the codes and my notes and all the data that I'm using, like in this video I'm using housing.csv. I save everything over there. If you want to download it for free, you can just click on this button after subscribing to my YouTube channel, and it will redirect you to this Google form, and it needs some basic information like full name and email address, etc. I'll be using this email address to give you the free access to my Google Drive, and the codes that are saved in the Google Drive are completely free for everyone. You can use them for your personal uses. There are no copyright issues. It's completely free. The one and only condition that has to be satisfied is that you should be my subscriber. I need your support because I have posted a lot of videos on this YouTube channel and I have not yet got enough subscribers. Someone asked me on a video that why I'm hiding the number of subscribers. The reason is that I'm not having enough subscribers to show. I'm putting a lot of efforts here. So I need your support, and I need it because I want to have the same motivation all the time. Otherwise, like from the next time, maybe I'll start thinking that I should start posting. I should keep on posting videos or not, because I'm not having a lot of subscribers. Anyway, so I need your support. Please subscribe it. Please share it with the people that you think that are interested to watch this stuff. Also tell them to subscribe to my YouTube channel, such that they can get a free access to my Google Drive by clicking on this button. So let us start with the code now. As I already told you, I will be using housing.csv data here, and first of all, let's see what is a polynomial regression equation. And as we are doing polynomial regression analysis in this video. A polynomial regression is basically a regression equation where we don't have degree 1 variables. We have degree 2, which is quadratic or cubic, or even degree 4 variables. So this is an example of a polynomial regression equation. This is actually a quadratic equation. So we can see that we have one variable and a square of a variable. In this case, we have a square of the same variable, which is x1. This is an example of the polynomial regression, and actually it's a simple form, and it is a quadratic equation. And I'm also using a quadratic equation to do to write the code here. But you can do cubic or power 4 or power 5 degree equation. It's quite easy to to tweak it, to change it, I'll tell you how to do it. In this video, I'm doing a power 2 degree equation, which is a quadratic equation. And then for your practice, you can make it power 3, power 4, whatever you like. So let us start with the code. Import pandas as pd. df is equal to pd dot read csv housing.csv and then df dot tail. As I already told you, I'm using housing.csv file here, and index call is equal to 0. So you can see that we have the same data frame here that we use in the last one. Now in the last one I use stats model, and this one I'm going to use sklearn. So also, yeah, let's do some change in the last one. If you remember, for the simple regression analysis, I use rm and medv parameters to do the analysis. In this one, to have a change, I'm using lstat and medv. You can do the same with rm and medv for your practice, but I'm doing like regression analysis on these two variables. Okay, perfect. So we just need the first and the last column. We don't need these 3 column data. Many people actually tweak the original data frame. I don't like to tweak the original data frame. It's good to make a different data frame such that we can do all the work on a separate different data frame. I don't want to change, I don't want to touch the original data frame here. So I'm making df2 now, and df2, which is, let's have the same column names, is equal to df lstat, and similarly for df2 medv df medv. Perfect. So now we have a different data frame. Now I'll do all the work on this df2 data frame. I'm not gonna touch this main data frame, which is df. Let's keep it like this. Now in the last video, I don't remember, I didn't use train test split. Okay, perfect. Yeah, I didn't use it. So in this video, what I'm gonna do is I'm using train test split, which is actually under sklearn library. If you have watched my neural network videos, which I posted 1 month back, I use this train test split methodology in order to split the data into 2 different data sets. One is for training and another is for testing purpose. I'm doing the same here. I'm splitting into 2 different data sets. There are quite few ways to do it, to split the data, but I like train test split because it does 2 works. The first one is it's of course it splits the data, and the second thing is actually it randomizes the data as well. So I don't need to import the random library or import a random in NumPy library, and it does both of the work. So it actually reduces my work. So I'm directly using the sklearn library from sklearn dot model selection import train test split. Now make all these 4 different variables, which is xtrain, xtest, ytrain. If you watch my neural network videos on deep learning, you would be familiarized with this way of splitting the data. Okay, so sorry, df2. My x-axis is medv and my y-axis is lsat. Perfect. So this is xtrain, xtest, ytest, Prani. Okay, ytrain. Perfect. Okay, all these variables are not in data frame format, so let's convert it into data frame format. It's quite good to analyze it in a data frame format. So we know how to do it. Let's make a different variable called xtrain df, and it will be pd.dataframe and then xtrain. Perfect. So now we have a data frame. Yeah, the good thing to notice here is that we can see that the index numbers 149, 47, 156, 283, 152. Train test split has randomized the data, which is a good thing. Actually, it's a very good thing for doing analysis like regression or neural networks or machine learning, because we need to randomize the data. Otherwise, the model will not learn it properly. Perfect. Actually, I should do the same with test also. We could make a for loop here in order to do it, but I like to use this commas. It's cool to use it. In the same line, I'm doing two things. X test. I always like to check before proceeding. Perfect. So we have split the data. Now, this is the equation that I'm going to make here. We already know that we have our x variable here, which is xtrain here, which we are going to use it for training the model. But we need x square also, which is square of xtrain. How to do it? There are multiple ways to do it. You can use NumPy library and square the entire data frame, which is quite easy to do it. But I like another way, which is actually using sklearn library and using polynomial features. The reason for using this library is actually, let me first import it. Sklearn dot preprocessing, import polynomial features, and let's make a variable called polynomial feature. The reason that I like this one is that you just need to write the degree inside the parenthesis. If you want to make it a 3-degree equation, the the regression equation, which will be b0 plus b1 x1 plus b2 x1 square plus b3 x1 cube, then you just need to do degree is equal to 3 and everything will be done. If you are using NumPy library or to square it, then if you have to tweak it to a degree 3 equation, you'll have to change the entire code. So that's why I like this way to do it. So poly is equal to polynomial features, degree is equal to 2. Now let's convert our xtrain. This is the variable poly.fit transform, and then inside it I'll be using xtrain df. Perfect. So you can see that actually I should do it like this. Yeah, perfect. So you can see that what it has done is it has converted this data set into 3 different elements. The first one is this one, the first one, for example, 16.6, so 16.6 to the power of 0, which is 1, 16.6 to the power of 1, which is the same number, 16.6, and 16.1 to the power of 2, 16.1 square, which is 259.21. If I make it 3, then now it's a 3-degree equation. Okay, sorry, I was getting confused that these numbers are changing. These numbers are changing because I am also randomizing it. It is randomizing it. So we're right. So we can see that if we make it 3, and we'll also have to run it. So actually this is e to the power of 1, which is actually 13.3 also, 13.3 only. So this is 13.3 to the power of 0, 13.3 to the power of 1, to the power of 2, to the power of 3, etc. But in this one, I'm doing power 2, degree 2 equation, which is a quadratic equation. Perfect. So actually, let's make the same for testing data set, which will be exactly the same, except perfect. Now now let's make the model, which is like as I already told you, I'm going to use Sklearn library here to do the regression analysis. Now again, one more important thing that I should mention here. I have converted the x variable into x square variable using this polynomial features. So now actually what we can do is we can consider, for example, in this one we can consider x1 as a different variable and x1 square as a different variable. So if you consider x1 square is equal to, say, z, so we have a linear equation, we have a regression equation of y is equal to b0 plus b1 x1 plus b2 z. Now if you see it like this, in this format, you can say that it's a type of linear equation, right? Because I'm having a different variable called z. I'm not saying it as considering it as x squared. I'm considering it as z, a completely different parameter. So I can use the linear regression analysis for the same thing, because I have already converted the x into x squared. So what I'm going to use here, what I'm going to do here is I'm going to use this x squared data rather than the third variable, which is z, which is the z data. If we would have a different variable called z. So from Sklearn import linear model, I'm doing linear model analysis here. Model is equal to linear model dot linear regression. Model is equal to model dot fit, and then I'll have to input the x train poly. It will be taking the entire, like, all the 3 variables. The first one is 1, which is not the 3 variables, the 3 parameters. The first one is 1. The second one is the element to the power of 1. The third one is the element to the power of 2, which is square of this one, and it is considering it as a linear equation. So we need to do it on x train data set. Perfect. The model is done. So now let's make the equation. This is the coefficient. Again, we should have two different coefficients. Just ignore this one for now. We should have two different coefficients. This is the coefficient number 1, which is b1, and this one is b2. If it were degree is equal to 3, then we would have 3 different variables. We can check it actually. You can see we have this is 0, this is b1, b2, and b3. So this is the coefficient. So let me give it a name, which is coefficient is equal to this. Also we need the intercept, which is this one. This is the intercept, which is actually b naught. Perfect. So now let's make the linear regression. Before making it, actually I should show you the scatter plot of actual data. So import the most useful library for plotting, which is matplotlib.pyplot as plt.scatter, and then x-axis is df2 medv, and y-axis is df2 lstad. Let's use color is equal to blue. Beautiful. So yeah, this is the scatter plot. Now you can imagine that we would have our regression curve to be like this. It should have a curve like this, right? So now let's plot our regression curve. Let's make the regression equation first, and then let's plot it. So in order to make it, yeah, actually I'll have to have an x-axis, some numbers on x-axis, and then for those numbers I'll have to have the value of y-axis using the regression equation that we made. So for that I'll have to import numpy as np. What I'm doing here is actually I'm making an x-axis of numbers from say 5 to 50 by changing it by 0.1. I'm going to use np.arange here. You can also use np.linspace if you want. It will also do the work. It will throw an a list actually, and this one np.arange actually throws an array, but you can convert a list into an array by using np.array. You can use np.linspace, but I'm going to use here np.arange from 5 to say from 5 to 50, 0.1, and for all the values in x-axis, the response, actually I use the same here, same variable here, which is response. So I'm gonna stick to that. Response is equal to the regression equation, which is intercept, which is b naught. I'm actually writing this equation now. B naught plus b1, which is coefficient, but the zeroth element of coefficient was, if you remember, it was 0. The first one was actually b1 and the second one was b2. So coefficient, the first one, and multiply by x-axis, and similarly coefficient, the second element, multiply by x-axis square. So we have this linear, it's not linear, we have this regression curve. So now let's plot it. plt dot plot. X-axis is actually x-axis and the y-axis is response. Let's make it red. Beautiful. So it's amazing, like this we can see that this regression curve has actually covered a lot of data. So we've got a very beautiful regression curve, which is this red one. Actually it's looking quite beautiful. Actually I didn't practice it before making this video, but actually it's looking quite good. Perfect. Now if you remember, in order to check the, I would say, efficiency of this model, we have a variable called r square, or adjusted r square. In the last one, if you remember that there was a very easy way to do it called model.summary, and then we got r square, adjusted r square, and not just these two parameters. We had got like a lot of things like Durbin-Watson parameters, skewness, kurtosis. This is the entire ANOVA table, t statistics, etc. Unfortunately, there's no such facility here. In order to do it, for r square, we'll have to use sclearn.metrics. It's a different way to do it. I'll have to write a couple of lines in order to extract the r square data, but we don't have any facility to get all this details. This is one of the reasons that I like this library, which is stats model library, more than sklearn. Actually, you can do this polynomial regression analysis using the stats model library as well. The only thing that you need to do here is rather than doing the this plus different variables, you'll have to create a variable which will be square of the first variable, and then you'll have to name it. For example, name it LSTAT square, and then write LSTAT square here with LSTAT, and just keep these two variables and do this analysis, and I think that you'll get the same results. But in that, you'll have the facility to use model.summary and get all the details here, which is quite useful. This is one of the reasons that I like stats model library more than sklearn. But still, how to do it in sklearn? From sclearn.metrics, import r square. R square, we need some prediction data, and then y test. Okay, this is model dot predict x test poly. Perfect. So we've got our r square of 65.63%, which is a lot, which is quite good. If you see that in the last one, although we did we use different independent variables, which was rm and medv, we got the r square data of around 50%, which is actually 51.4% to be precise. But in this case, we have got it more than 60% r square, which is quite good. If you do this analysis on stock price data, and if you get this high r square, which is actually impossible to do it, but still if you get it, then you'll make a lot of money. If you do this analysis on stock prices, you'll get the r square value of around 2%, 3% maximum. And that is the reason that it's quite difficult to predict the stock prices. You'll have to go do more analysis. Even neural networks, deep learning, cannot do the best work to predict the stock price data. But still, there is a lot of work that is being done on the stock price prediction. Many hedge funds are doing it a lot. For example, in factor investing, there are some hedge funds that are using the neural networks in order to make different factors. They are not considering factors that are like value, growth, style, momentum, etc. They're using neural network and the number of nodes as different factors in the neural network, and through that they are like diversifying their portfolio by changing the weights on the number of the different nodes on the first or the second layer that they're using. I know that all this information cannot be grabbed that easily. Many of you cannot understand what I'm saying, but still there's a lot of work that is being done right now on this quantitative analysis, and this is actually one of them that is doing the polynomial regression. So perfect, we've got a very good R square, which is 65.6%. So I think we are done with it. In the last video, let me check if I missed something in the last video. You can plot these graphs if you want to. You can like make an error parameter, which will be the subtraction of the response and the LSTAT. I am not going to do it. Like, this is easy stuff. I already explained it in the last one, so you can do it. So I think we have completed all important things. I hope you liked my video, and if you wanna watch this type of videos, this type of stuff in future, then please subscribe to my YouTube channel. I need your support. Also, if you know anyone who is interested to know all these things, then forward it to him or her, and also recommend him or her to subscribe, because I need some subscribers before going forward. I have a lot of stuff to share. I love Python. I used to do Python coding a lot. I'm a finance professional and a Python lover, so I just try to implement both of these things in order to optimize this industry as much as possible. But for that, I would need your support to continue. Just subscribe to my YouTube channel. I'm giving everything for free. All this stuff is for free. These videos, I used to post these videos like on all I would say every week, sometimes twice a week. So I'm putting a lot of efforts. I'm giving all my codes for free, and not just codes, a lot of different stuffs that are actually on Google Drive. If you go to my Google Drive, you will see there are many things that over there that you can use for free. The only thing that I want from you is that I need some subscribers. So please subscribe to my YouTube channel. So thank you so much. I hope you like my video. Stay tuned for my future videos. See ya.